Renegade. Yes, I did just say that, folks. That's for you, Tessa and Kate. We're going to go ahead and finally get to chapter 9. No, it's been a while, but here we go. So, chapter 9, lesson 1 is all about statistics, kind of an introduction to what are statistics. And we should be looking in our green math books. Remember that we're looking at our book while I'm pulling these examples. And the page we're on today is going to be 392. So get there in your math book, and we always start with our learning target, remember? So this is about statistics. So our learning target today is going to say, I can use dot plots to answer statistical questions. So we'll get that written in first. So today we're going to learn what is a statistical question, and then we're also going to see or remind ourselves what a dot plot looks like. So at the top of page 392, let's go ahead and take a look at some of those highlighted words. It says statistics is the science of collecting, organizing, analyzing, and interpreting data. And data is kind of this general term for information. So when we're looking at data in math, we're looking at information that comes in using numbers. So let's start out with that word statistics. And to kind of summarize that sentence, we can say collecting and analyzing data. So that's what statistics are. And then keeping reading up at the top of 392, it says a statistical question is one for which you do not expect to get a single answer. Instead, you expect a variety of answers, and you're interested in the distribution and tendency of those answers. So that's kind of what we're going to focus on in this lesson. So we're going to write statistical question. And reading what we just read there, a statistical question has lots of different answers. So you can't just say one thing when you're asked this question. So there is no single answer. And another way of saying that would be there can be many answers. So an example of a statistical question off the top of my head would be, how tall are you? If I asked a whole bunch of people that question, you wouldn't just hear one answer over and over. You'd hear a ton of different answers. So those are types of statistical questions. So now that we've got those vocabulary words, then we can get right to our examples. There's a little bit of more writing than usual because we're talking about data and statistics in this lesson. So you'll see that in this chapter as a whole. So example 1, this is all about answering statistical questions. So we'll get example 1 down. And the question on 392 says, you conduct a science experiment on house mice. Your teacher asks you, what is the weight of a mouse? Question A says, is this a statistical question, and explain. So first of all, let's get down the question that our teacher asks us. It says, what is the weight of a mouse? What is the weight of a mouse? So that's the question we're taking a look at. So in item A, we need to figure out, is this a statistical question? So remember, a statistical question, there is no single answer. There can be many answers. So if I asked a group of people, what is the weight of a mouse? Would we get one answer every time, or would we get a ton of different answers? We'd probably get a ton of different answers because every mouse is a little different. Depending on how much cheese you've eaten, of course. So we would say that this is a statistical question. Yes, because you could say that the weights of mice could all be different. Lots of different answers could be given here. So that's question A. And then question B says you weigh some mice and record the weights in grams in the table. Display the data in a dot plot and identify any clusters, peaks, or gaps in the data. So if you look at the left of the question, there's a little chart with a whole bunch of different weights of mice. They want us to take that and make a dot plot of it. So let's start out with, yes, I know this is annoying, but copying down those numbers in the chart. So these are going to be weights of house mice in grams. And we're just going to copy down these numbers quickly so that we can get them into a dot plot. Remember, we have to have the original in our notes as well as the graph so that we know where we came from. So the numbers on the left column, we've got a 20, an 18, and a 28. 20 and 19. That's the first column. Moving over to the next column, we have 19, 20, 23, 21, 22. Next column over, we've got a 21, 27, 20, 18, and a 21. And our last column, 20, 21, 19, 27, and 20. So those are the weights they give us. We're going to now make a dot plot. So over here, I'm going to label our graph dot plot so that we remember, looking back at our notes later, what this graph is called. And remember, these are weights of house mice. So I'm going to put mice at the top as my title. The way we create a dot plot is we start with a number line. And on that number line, we have to have tick marks with numbers. Remember, anytime you label any kind of graph, no matter what, you have to pick a scale or a consistent pattern on the bottom that you're going to label by. One thing that's nice, though, about dot plots is that you don't have to start with a 0 here. You kind of just can pick the numbers that you start and end with, as long as you have a pattern you're going by on the bottom or a scale. So if we look at our numbers over here in our chart, the lowest number on our list is an 18. So I'm going to start my dot plot here with an 18. And then the highest number I see on our list looks like 28. So let's see if we have enough to go by ones. I think we do. So let's go by ones. And label every tick mark. And even though we have a couple extras, I'll go ahead and just knock some labels on those too, just to make it look nice. So once you've got your tick marks labeled with a consistent pattern or scale, then we come over here and we basically just put dots above the tick mark where these numbers are. So if I see a 20, I'm going to put a dot above the 20. If I see an 18, I'm going to put a dot above the 18. And then you keep going to make sure all of these numbers are represented. I have a 28 and a 20 and a 19. Okay, so here's my second 20. So we just stack it on top of the first one. So basically you're going to make a stack of dots. And then you've got a 19. There's my first row. Next row, 19, 20, and 23. So we have a 19, a 20, and a 23. 21, 22. And you see how my first dot is kind of trying to get lined up here. So I want my dots to kind of be lined up in rows as they increase higher. We have a 21 and a 22. 21, 27. 20, 18, 21. Then last row, we have a 20, 21, 19. 27, 20. So now that we've got every single dot on our dot plot, we can answer some questions using our dot plot. So back to question B, it says to display the data in a dot plot. We've done that. Then it says identify any clusters, peaks, or gaps in the data. So over here, I'm going to put a little asterisk because these are some important vocabulary words we're going to want to take a look at. The first one they said was cluster. Then they said to look at any peaks and then gaps in the data. So we're going to talk about each of these words. So a cluster is kind of taking a look at all of the dots on our graph and asking ourselves, is there any spot where most of the dots kind of cluster around or kind of group together? And if you look, there's a big cluster right here where a lot of them are really tall. Most of our dots are right in here. So I would say the cluster would be right in this area. So like 19 to 22, that section. So I could say something like from 19 to 22, there's a cluster of dots. And then our peak is kind of like a mountain peak. So if you're looking at this like kind of like a mountain, the tallest part of the mountain would be our peak. So our peak would be at the 20. And then if we're looking at gaps, we're looking for spaces that there's no dots, and there's dots on the left of it and dots on the right of it. So you can see that all these dots are kind of connected together, and then it stops for a little bit, and then it starts again. So this little space here would be called our gap. So there's a gap between the 23 and the 27. So those are cluster, peak, and our gap. And I'd forgotten to put our label on the bottom, but it is important to label what our numbers mean. And these are weights in grams, so I'm going to put that label down here. So if we were going to look at this graph and read it, even though we didn't know what the question started with looking like, we would know how to read this graph. And that's example 1. So you can pause the video. Oh, I'm sorry, there's one more. Question C says, use the distribution of the data to answer the question. Okay, so here's question C. Looking at the distribution of this data means to look how spread out the dots are or how clumped together they are. And they want us to answer the question. And remember, the original question was, what is the weight of a mouse? So remember, this is going to give us lots of different answers. We could say 18 grams or 27 grams. But if we were going to answer this question kind of in a general answer, we could say about how much do most mice weigh? And it looks like most mice weigh about 20 grams because that's our peak. So we can say that for our answer. Most mice weigh 20 grams. So we can kind of use a general statement there. All right, pause the video if you want to try it on your own at the bottom of 392. Okay, if you tried it out, it says the table shows the ages of some people who retired early. The question is, how old are people who retire early? So if you look at those ages, they want to know, is this a statistical question? So if you answer that correctly, you would say, yes, it's a statistical question because there's lots of different answers people can give. And then B says to display the data in a dot plot. So putting your number line out and putting all your dots in there, and then identifying clusters, peaks, and gaps. So if you said clusters, you would say there's a cluster probably around the 59 to 61 range. The peak would be at 60. And there's actually 2 gaps in this one. There's a gap from 56 to 58, and then there's also a gap from 62 to 64. And then we have to use the distribution to answer the actual question. So you could say on this one, most people who retired early were about 60 years old. So those are your answers to your on your own question. Let's go ahead and get to example 2 now. This is going to be our last example for the lesson, since these examples can be a little lengthy because there's lots of different parts to them. This one's going to be using a dot plot. It says you record the high temperature every day while at summer camp in August, and then you create a vertical dot plot. So if you look at this thermometer on the right, this is called a vertical dot plot because the dots are kind of shooting out sideways rather than going up from the number line. So what we're going to do is create this thermometer in our journals so that we have some kind of example of a vertical dot plot. And we want to make sure that it's big enough to where we can get all of our tick marks on here, no problem. So the top line on our dot plot represents 87 degrees. And then it goes all the way down to 80 degrees. So just make sure you can get all of those on your vertical number line. Mine was just about perfect there. So then our dots are actually going to come out on this side of the thermometer since it is a vertical number line. And it looks like our thermometer is right in between here. If we wanted to color it in and show the temperature on this thermometer, that's what it would kind of look like. All right, now we just have to put in the dots the way they have them on the picture here. So it looks like there's 4 dots on the 87. Looks like there's 1, 2, 3, 4, 5, 6, 7 dots on the 86. 3 dots on the 85. 1 dot on the 84, 2 dots on the 83, 3 dots on 82, 1, 2, 3, 4, 5 on the 81, and 3 on the 80. So basically just copy down what we saw in the book to make sure we have that in our notes. Now we can actually answer the questions. So question A says, how many weeks were you at summer camp? So if we look back at the top section, if we read carefully, these dots represents each day. So to answer this question, we need to know how many days are in a week. Well, there's 7 days in 1 week. That helps us. And the question here, it says how many weeks? Well, if each of these dots represents a day, and we count up how many total we have, looks like we have 28 days. So if I have 28 days, and there are 7 days in a week, if I divide 28 by 7, I would end up getting a total of 4 weeks. So this data display represents 4 weeks of temperatures. Question B says, how can you collect these data? What are the units? So when someone is actually measuring temperature, there's 2 different measurements you can use. Remember, there's Celsius and Fahrenheit. If you look at these numbers, they're in the 80s. 80 degrees Celsius would not work for a day in August at a summer camp if you thought about how hot that would be. So we're actually going to use Fahrenheit here for these ones. So what are the units that we're using? We're using degrees. Fahrenheit, that would be the abbreviated version, or you could spell out the entire word Fahrenheit if you wanted to. So degrees Fahrenheit would be our units. And the last question says, write a statistical question that you can answer using the dot plot and then answer your question. So remember, a statistical question is one where you'd have lots of different answers. So if you look at these are lots of different temperatures. So we could write a question, and there could be lots of different questions you could say here. But one way we could write a question with lots of different answers would be something like, what is the daily temperature in August? And then you could see there's lots of different answers for that. So we could say, what is the daily temperature in August? Okay, so that's our statistical question. Reminding us with that little label there. And then our answer to this, well, there's lots of different answers, but you could say that there's a kind of a range of answers here between 87 degrees and 80 degrees. So you could say it ranges from 80 degrees Fahrenheit to 87 degrees Fahrenheit. So that would be the answer to our statistical question. If you want to pause and try something like this, you can try the on your own number 2 at the bottom of 393. Okay, if you tried that, A says, how many students ran in the race? So if you answer that one, you would say 20, count up how many dots there are here. B, how can you collect this data? What are the units? Well, if you read the top here, it says the dot plot shows the times of 6th grade students in a 100-meter race. So these are going to be times. So the units would look like they'd be in seconds here, looking at the different numbers on the bottom. Those are probably seconds. And then C, write a statistical question that you can answer using the dot plot and then answer the question. So remember, there's lots of different questions that you could ask. One example would be, how long does it take a 6th grade student to run 100 meters? And then that's how you would get the answers that you see on the dot plot. If you were to answer that question, you would say it would probably take most 6th grade students about 13.8 seconds to run 100 meters because that's where our peak is in our data. So that brings us to the end of lesson 1 in chapter 9.